And question number 4 is the same question we did in 6.1, but in 6.1, we did it in degrees. So the only thing different here is what I underline in green, is that it says in the domain from negative 2 pi to 2 pi, that means that you're going once around the circle in the negative direction and once around the circle in the positive direction. This is like going from negative 360 to 360. But the question's in radians. But we do everything the same when we're solving a question in radians as if we were solving that question in degrees. The only difference is our calculator's in radians instead of degrees, and our answers look different. So what does that mean? I've got the point negative 4 comma 3. Can I draw that? 1, 2, 3, 4, 1, 2, 3. There's negative 4 comma 3. It's a terminal point. So here is my angle theta in standard position. In the positive direction, we could have theta in the negative direction go there as well. How did we solve these when we had degrees? We first found our reference angle. Where's our reference angle? The reference angle definition is it's always the angle between the terminal arm and the nearest x-axis. It's trigonometry. We need to draw a triangle. So I'm going to draw the triangle down to include my reference angle. And because I know this point, I know how long this side is, and I know how long this side is. I know this is 4, and this is 3. Using grade 10 trigonometry, I could figure out what my reference angle is. Tan of my reference angle is the opposite side, which is 3, over the adjacent side, which is 4. I could go to my calculator and find my reference angle. And now this is where it's important that we're in radians instead of degrees. So I can go tan inverse of, is it 4 over 3 or 3 over 4? 3 over 4. And my reference angle is 0.6435. And so this is a weird answer because we're just not used to radians. Remember, 1 radian was about 57 degrees? So 0.6 of a radian, around like 37, 38 degrees. Now, if we were doing degrees and this was 37 degrees, how would you find the black angle? The black angle theta would be 180 minus 37 degrees. Does that make sense if it was in degrees? But now we switch our brains and we think in radians. Instead of doing 180 minus to find this angle, I'm going to need to do pi. 1 pi. 1 pi minus my reference angle. So I'm going to write here, this would equal pi minus my reference angle. So the angle theta, go to my calculator, and I would go, oh, sometimes you need to use your reference angle more than once. And if you don't want to round it early, above my on button, there's a store button. All calculators have somewhere where you can store an answer. So you can choose any letter. I'm just going to store it as x. And so now it's remembering that x is equal to this, which is nice because I now want to go pi minus this number, but instead I can just write pi minus x. And I get 2.5498. Does it say to the nearest tenth? 2.5. This would be the only answer from 0 to 2 pi. We also need to figure out this angle, the negative angle. If I was thinking in degrees, do you see that you could do 180 plus your reference angle and make it negative? So if I was going to my calculator, I'm now doing pi instead of 180, plus my reference angle, which I stored as x. I get 3.78, which gives me negative 3.8. So we now solve for theta in the domain that they asked, once around in the positive direction, 0 to 2 pi, once around in the negative direction, 0 to negative 2 pi. In part B, they say, given cotangent of theta is equal to negative 2, here I would switch it right away to tan, and here I would flip the fraction to 1 over negative 2. According to your cast rule, where would that be? Tan is negative in quadrant, close, quadrant 2, and quadrant 4. If I draw it in quadrant 2, tangent is opposite over adjacent. Here's my reference angle. If I draw it in quadrant 4, I'd go back up. My opposite would be 1. My adjacent would be 2. Okay? How would I find that reference angle? Well, tan of my reference angle. And when you're finding a reference angle, your reference angle is based on an actual triangle. Actual triangles have actual lengths that are all positive. So even though tan is negative 1/2, when finding your reference angle, you have to use positive values. I go to my calculator. I go tan inverse of 1/2. I get 0.464. Since I'm probably going to use that a lot, I'm going to store it as x. How many answers are we going to get? We need to solve it between 0 and 2 pi. Can you see my positive ones? I would get this angle as 1 theta, this angle as another theta. In the negative direction, I would get this one and this one. The one in quadrant 2. Does it make sense that halfway around is pi minus your reference angle? Oh, so you have to answer the rest of these by just putting the values down. So we've got 2.67. This one's going to be 2 pi minus your reference angle. Here we're going to get negative your reference angle. And we have 2 other ones to find. If you want to circle the questions on this one, the questions are 13 and 14.